The journey of this product begins at the loading dock, where a forklift rumbles past oil-stained concrete and flickering fluorescent lights. In its worn wooden crate, dull gray aluminum forgings clatter softly, coated in a thin film of transport oil. Nearby, steel bars and polymer pellets wait their turn. Everything smells of diesel, cutting oil, and warm metal, the raw pallet from which a precise mechanical instrument will be born. Inside the machining hall, the first transformation begins. An operator in stained gloves locks a raw forging into the jaws of a vertical machining center with a heavy, final clunk. Behind scratched safety glass, the spindle spins up with a rising whine. A broad milling cutter skims across the top surface, shaving the forging flat and true. White coolant erupts around the tool, turning into a frothy storm as bright chips slam against the enclosure walls. What was once an anonymous lump of metal now has its first precise face. Bit by bit, the forging is hollowed and defined. A drill plunges into solid aluminum, scattering curling chips as neat holes appear where pivot points will live. Long-end mills carve deep internal cavities, the machine shaking under heavy cuts as heat and friction squeeze smoke out of the coolant mist. Specialized tools push through narrow channels, forcing metal aside with tremendous pressure to create sharp internal corners and complex pockets. Each tool leaves its own signature, rough, then smoother, then almost glassy surfaces where moving parts will one day glide. The work shifts from brutal to delicate. Small reamers creep through earlier holes, shaving away microscopic amounts of metal to achieve flawless circles with mirror-bright walls. Tiny drills peck carefully at slim walls to open passages for pins and springs. Fixtures turn and tilt, presenting each side of the part to the spindle like a sculptor rotating a statue. By the time the part leaves this machine, its silhouette is unmistakable. A rigid frame, a cavity for controls, a path for energy to flow, and precision points where other components will eventually lock into place. Human hands take over at the edges where machines cannot feel. At a deburring station, a worker presses the sharp corners against a rotating wheel, erasing burrs and softening edges that could cut skin or snag moving parts. Fine gray dust hangs in the air, clinging to his mask and glasses. Other parts tumble together in vibrating bowls full of ceramic stones and water, rubbing each other smooth in a constant rumble that feels like a small earthquake underfoot. When they emerge, they are still raw metal, but now tactily safe, ready to be handled and assembled. Cleanliness is next. Racks of parts roll into industrial washers where hot, pressurized water and detergent blast away oils, chips, and sludge. Steam pours from the seals, fogging the room as the metal warms. From there, the parts descend into chemical baths. First, an acid solution that microscopically etches the surface. Then, an electrolytic tank where current transforms bare aluminum into a hard, protective oxide layer. Bubbles cling and rise around each piece as the invisible electrical reaction thickens their skin. Color and permanence arrive together. The newly hardened surfaces, still porous, are dipped into dark dye. Slowly, they drink in the pigment, changing from pale gray to deep, matte black. Afterward, a hot sealing bath locks those pores, steam rolling off the tank as salts crust along its rim. When the racks lift free, the pieces gleam with a subdued, purposeful finish, neither flashy nor fragile, but built to endure rough handling and harsh environments. Now the factory turns its attention to steel. Long, dark bars are hoisted by cranes and fed into machines that bore perfectly straight holes down their centers. high-pressure oil roars as specialized tools tunnel through solid metal, leaving behind smooth internal channels. Another tool follows to refine the bore, polishing away tool marks until reflections dance along the inside of the tube. Deep within, invisible geometry takes shape, the subtle twists and lands that will guide spinning projectiles with silent authority. These steel tubes are stressed, heated, and relieved. Carving their internal patterns leaves tension locked in their walls, so they are loaded into furnaces that glow with orange heat. Inside, temperature and time work together to relax the metal's memory. Later, lathes tear away blue-hot ribbons of steel from the outside, sculpting elegant contours that balance strength, weight, and heat management. Threads are cut at one end. A complex chamber is formed at the other, where pressure and timing must be controlled with microscopic precision. Surface treatments harden these components even further. Some barrels sink into bubbling chemical baths that darken and protect them with a tough, textured finish. Others are immersed in molten salt, undergoing a deep unlocked, diffusion-based treatment that changes the very skin of the steel itself. When they emerge, they are no longer just tubes. They are critical, hardened conduits ready to channel violence in a way that must remain strictly controlled and predictable. Smaller steel parts go through their own ordeals. Internal components that will lock in, rotate, and bear stress are machined from specialized alloys, heat-treated until they glow, and then quenched to entrap carefully tuned hardness within their crystalline structures. They are inspected under ultraviolet light after being dusted with magnetic particles, revealing any hidden cracks as glowing lines. Under microscopes and optical comparators, their silhouettes and internal grain structures are compared against tight tolerances. Only the ones that pass these invisible tests will ever be installed. Parallel to the metalwork, polymers take shape. Pellets of engineering plastics tumble through clear tubes into molding machines. The molds close with a heavy clamping sound. Molten material is injected under high pressure. When the mold opens, familiar shapes drop free: grips, stocks, followers, and panels, all textured for human hands, all warm and slightly soft before they cool and harden. Springs made from high-performance wire coil and snap, some heat-treated to remember their shape through thousands of compression cycles. Assembly brings all these worlds together. On long rows of benches, workers fit tiny springs, pins, and levers into the machine frames. They use specialized punches and jigs to guide roll pins into place without marring finishes. Safety mechanisms are built up piece by piece, detents and cams fitting together so that a simple thumb movement will switch mechanical states with a crisp click. Control groups are pinned into position, checked by feel. Does the motion stack? Does it reset cleanly? Does it match the expected weight? Elsewhere, barreled assemblies come together. Hardened tubes are aligned with rigid housings. Nuts are torqued down with lubricated threads until geometric relationships line up within fractions of a degree. Slim stainless gas channels are pinned into blocks and aligned with precisely drilled ports, forming a hidden nervous system of energy transfer. Lightweight handguards slide over mounting surfaces, then clamp into place, free-floating yet rigid. Their slots and rails ready for accessories that will never appear in this story. Once upper and lower assemblies are complete, they meet for the first time. Two pins are pressed through matching lugs, binding metal to metal. The combined shape is instantly recognizable as a single, unified machine. Operators cycle the action by hand, listening to the rhythm of parts sliding, locking, and releasing. Without a single round fired, they can already tell whether this mechanism has the right sound, not too gritty, not too loose, not too tight. Then comes the controlled violence of testing. Behind ballistic glass and into contained traps, a small number of live rounds are fired through select units. Casings fly, impacts thump, and sensors record pressures and timing. The hot brass is gathered and examined. Marks, expansion, and primer condition tell a story about how the system behaves under real stress. These tests are carefully bounded, tightly monitored, and essential for ensuring that each machine operates within safe predictable limits. From there, a new cycle of cleaning and inspection begins. Carbon fouling is scrubbed from surfaces. Thin oils and greases are reapplied exactly where needed. Preservative films are sprayed onto complete assemblies as they ride through a misting tunnel, ensuring they will resist corrosion in warehouses, trucks, and storage rooms far from this factory. Lasers etch identification codes into hardened surfaces, writing each machine's unique identity into metal for regulatory traceability and accountability. Quality assurance surrounds everything like an invisible web. Coordinate measuring machines touch reference points with ruby-tipped probes, confirming dimensions down to thousandths of an inch. Microscopes peer at cross-sections of steel to verify that heat treatments reach the right depth. Salt fog chambers bathe samples in corrosive mist for days, ensuring coatings will withstand years of harsh conditions. Drop tests and impact tests verify that sudden shocks will not cause unintended behavior. Torque wrenches, gauges, and fixtures are themselves calibrated in quiet labs to ensure every reading they gave on the line was trustworthy. All along, waste is managed and recycled. Metal chips are squeezed into dense pucks to reclaim precious coolant and reduce scrap volume. Dust collectors pull fine particles from the air, separating breathable space from hazardous residue. Used solvents, spent solutions, and contaminated sludge are sealed in clearly marked drums, loaded onto specialized trucks, and taken away under strict regulation. Even the test fire traps are periodically cleaned of heavy fragments, reclaimed under protective gear. Meanwhile, life in the factory continues around the machines. Workers tape their thumbs before long bouts of loading test magazines. They wash metal dust from their hands, but never quite get it all out of their fingerprints. They eat meals in break rooms with vending machines that reflect the glow of the shop floor behind them. Forklifts refuel, time clocks beep, and shift changes bring waves of tired bodies in and out through scuffed doors. Engineers watch from mezzanine windows with chipped coffee mugs, monitoring trends and yields instead of individual bolts or pins. At the end of the line, finished products pass through one last quiet ritual. White-gloved hands wipe away fingerprints and smudges, leaving clean, even finishes. Manuals and security devices are added to each box. Foam is cut precisely to cradle the machine inside. Cardboard closes with a heavy fold. Tape guns scream and snap. Pallets are wrapped in plastic until they shine like solid blocks. Barcode scanners log each serial into encrypted records that will track these objects wherever they go next. Finally, under a rising roll-up door, bright daylight floods the shipping bay. A truck reverses into the opening, engine idling, frame shuddering as pallets are rolled aboard. The load is secure, documents are signed, and the trailer's doors close. As the truck pulls away, leaving a faint haze of diesel exhaust, the building behind it hums steadily on. Inside, new forgings are already clamped in fresh fixtures, coolant pumps are circulating, and cutters are spinning up. The process never really ends. Raw aluminum, steel, plastic, and human effort move in one direction. Precise, tightly controlled mechanical systems emerge at the other. Between those 2 points lies noise and heat, dust and steam, meticulous measurement, and fallible human hands. What starts as anonymous material leaves as a complex machine, a creation powerful enough that its entire existence must remain bound by rules, responsibility, and control.